Dear students in the internet, good morning, good afternoon, good evening. My name is Markus Disse. I'm from the Technical University of Munich and I'm Chair Professor for Hydrology and River Basin Management. Welcome to the course Flood Risk Management, to the MOOC course Flood Risk Management. Today we want to talk about flood chain uncertainties. This lecture is divided in 3 videos. We want to start with precipitation. The next video will go about runoff, and then the last is routing. The course structure you see here as follows. Precipitation has uncertainties. The transformation of from precipitation to runoff in the catchment has uncertainties. And at the end, also the water levels, you will transform your discharge into water levels, has also some uncertainties. And we want to talk about that. The learning targets of our course is you should remember what is a flood chain, which interpolation methods do you have for precipitation mainly. Then you should understand all the modeling steps for flood inundation and their related uncertainties. Analyzing the usage of different model complexities is also an issue. You should differentiate between 1D and 2D models and which model can you use for different purposes. And last but not least, you can evaluate flood hazard and flood risk maps concerning their reliability and are they useful for further analysis, for instance. Okay, let's start with the precipitation. But first of all, I want to explain you this flood chain. The flood chain exists of precipitation, transformation of precipitation to runoff, and then the flood routing. Precipitation, of course, is the driver for all our floods. You have a heavy precipitation on your catchment. You have to calculate this amount of water, what is falling on the catchment. Then you have to transform this precipitation into fast components, fast lateral components, because part of the precipitation is infiltrating. The other part is going to run off, to the fast runoff, and this runoff forms the flood wave. And if the catchment leaves all the water to the river, then the water must be routed within the river. So you must have to know velocities, flow velocities, and water stages. So the main issue of routing is to transform the discharge, which is measured or modeled in cubic meters per second, into water stages, and therefore into inundation areas. This is the final goal of all our modeling. All these steps have uncertainties. All these steps have uncertainties. And here this picture is a nice one. You can say, let's assume we are here in the present day. We are standing at a gauge in the catchment, let's say gauge of Munich, and we are standing here and we are measuring this water level. This is about water levels. But we want to look a little bit into the future. There's a flood forecast. We want to know, is our house or our garden or so, is it safe or not for the next 2 days? And we have several possibilities to calculate these flood wave. For the next 2 or 3 hours, we can really rely only on measured water levels, which are upstream in the catchment. So the water levels are only routed downstream to our gauge Munich, and we can calculate new water stages. You can imagine that this uncertainty of measured water levels just routed downstream to our point is not so uncertain. So we have little uncertainties. If you want to look more into the future, let's say to the next 6, 8 or 12 hours, we have to rely on measured precipitation, because precipitation first falls on the ground, then it goes through the catchment to the river. That needs more time, and therefore you can look more in the future if you rely on measured precipitation. But here we have the problem that the precipitation is only measured in different points and not in the whole catchment, and there's an uncertainty. You don't know really the whole amount of precipitation which is falling into the catchment. So the uncertainty will be higher for forecasts based on measured precipitation. And last but not least, you want to look perhaps for the next day or next 2 days, what will happen with our flood. Then you have to rely on forecasted precipitation. Forecasted precipitation is a job of the German Weather Service or of other weather services around the world. And you know the weather service is not always very exact, and this is more or less a guess. And you have also to transform this forecasted precipitation to runoff and then to the routing process. Okay, and you see the uncertainties are getting bigger and bigger, and normally you cannot forecast more than 4 or 5 days. Then all the other things is chaos after that. Yeah, but now let's go to information. What information do we have in the internet? Bavaria is very well equipped in the information, in the internet-based information. So we have two portals here in the internet. One is the flood forecast portal from the Bavarian Water Authority. So here you can get the next forecasts, the next water levels for 1 or 2 days. And you can download all the data here at this internet address. Most of the German states have these kind of forecasts or information in the internet, and most other countries as well. In Bavaria, I'm from Munich, so let's go to Munich. You will find these information, unfortunately in German, not in English so far, about water level, discharges, location, where is this gauge located, inundation area, statistics, and so on, catchment data, and the runtime. I want only to pick up the water level here, because this is most important for the people who live in Munich. Is it dangerous or not dangerous, our water level, and what's about the future? Here we see a flood wave which occurred in 2013. This was a June flood 2013, and we had several water levels here, not the highest one. These levels 1, 2, 3, 4 are alert levels, and you can see what this means. The first one is not very dangerous. It's only for the foreland is inundated. That's not a problem. Level 2 is more for agricultural areas. Level 3, there you have some houses already inundated, and 4 is the highest level, and even the church, which is normally on higher ground, is inundated. These levels are individually fixed for each gauge, and so the people have information. What is an incoming flood wave? You have a forecast here, also with an uncertainty given in this information basis, and then you can see, okay, do I have to prepare something or not?